Hey, welcome. This is going to be our final part 4 of this lesson, and then we'll move on to more Unit 1 stuff. So we're going to take a look at functions, how they increase, decrease, and are constant over an interval, as well as the relative max min and behaviors. All important calculus concepts that you're going to play much more detail. We're just going to get familiar with them. That's going to be our objective here. So when a function is increasing, basically we're saying from going from left to right, the graph visually you can see it increase, but more importantly it's basically stating that f of x1 is less than f of x2. This is like the difference of our y's. It's almost like delta y right here, and this is my delta x. So as this increases, that increases as well. And conversely, when we talk about decreasing, when this increases, this decreases. My delta y will decrease. So this would be a decreasing, and of course we can have things like y is equal to 2.3 or whatever. We have a very constant straight line here for constant. So let's go ahead and find the intervals over this graph here. And this is continuous. This is a continuous little function here. On where it's increasing, decreasing, and constant. Well, visually we can see it's increasing here as we go from left to right. So as we say, as x is increasing, we're going to go from negative infinity to 0, and it tapers off just like the top of a roller coaster. And then that's going to be our increasing interval. Our decreasing interval is going to pick up right where it left off, and this is non-inclusive because at 0 you're going to learn some more concepts, and you're going to learn about tangent lines and things like that. This right here would be a tangent line where this slope is equal to 0. So that is a basic snapshot of increasing and decreasing. Very simple example here, and it can get a little bit more interesting as we move on into the course. Now next we're going to take a look at relative max and mins. I don't really have a specific example for that. We're just going to identify them on the graph, and right here where we have f of a, this right here would be a relative maximum, and this would be the absolute maximum on the graph. Now we know it's the absolute maximum because this arrow here and this arrow indicates there's not going to be any more turns to the graph. It's going to continue on infinitely down in negative directions for the y. So this would be relative. This would be a relative max, and this is the absolute max. Here we have a relative min and an absolute min for this graph. And those will come into play in some other definitions in the future as well. So what we're going to do, we're going to play around with, I'm going to give you a function, and you're going to find all these things to it. Now, end behavior is, I skipped that. Okay, so end behavior is basically how is the graph behaving as it basically goes off into infinity in one direction or the other. And you have three things. And this is all in relation to as x goes from left to right. So as x approaches infinity, going to the right, y will either be going to infinity, you're either going to be going to negative infinity, or it's going to approach a constant. It's going to be one of those three things. Very often, it's going to be y, it approaches 0. Very often it's going to be that. And then we're going to revisit, I already mentioned this before, continuous and discontinuous functions. Basically, is there a break? Is there something going on like this, where we have a function like this and like that? That would be a discontinuous function. Whereas if I had some kind of cubic or whatever like that, that would be a continuous function. All right, so we're going to put all the pieces together on an example like this. And here I have f of x is equal to negative 2 over x. And we can sketch that if it helps, but there's no reason to. Real quick, the graph would look something like this. Think about the logic of it. As x gets really, really small, and that's a negative x over here, you would find that this is going to get very, very close. If it's negative x, it's going to be positive because negative divided by negative is a positive. Y is going to get very close to 0, so it's going to come down like this. Okay, and it's not going to quite get to 0, but it's going to get awfully close. And when x is positive, the whole thing is going to be negative, so your y is going to be negative. And the bigger the x gets, the smaller the fraction. And the smaller your x gets, like 0.5, 0.2, 0.01, your y is going to get rather big, but it's going to be negative, so it's going to look like this. Right. So here we have a discontinuous function, so I already know that this is going to be discontinuous. There we go. And let's go ahead and do the domain, range, and et cetera, et cetera. So the domain, it is not all real numbers, because here we have x in the denominator, and we can't let x equal to 0. So it's a set of all x's such that x is not equal to 0. In interval notation, I would write it like this, 0, and I'm going to union that with 0, positive infinity. Okay. My range is going to be very similar. It's going to be all the y's up and all the y's down, but it doesn't quite touch 0. So this is going to be, basically I could clone this and write it again. And 0 to infinity. Now look how we did this. We went from bottom up. Okay. Zeros, there are none because it doesn't cross the x-axis, and y-intercept, it doesn't cross that either. Symmetry, we do have symmetry. It is actually symmetry with the origin. We can prove using our test of f of negative x. All right. If we put in f of negative x, we're going to get is equal to negative 2 over negative x, which is equal to 2 over x, which is the same thing as negative f of x. All right. So when we have f of x is equal to negative f of x, we know we have an odd. And yes, it's about the origin. End behavior. So as end behavior goes, as x approaches infinity, as x approaches this way, it gets very, very close to y is equal to 0. So y will approach to 0. Doesn't touch it, but it approaches. As x approaches negative infinity, here we go. We're getting very, very close. Again, y is going to approach 0. I could translate this up and down and so on and have different things. Increasing interval, it's increasing here, and it is increasing here. Remember, we're going from left to right. So it's basically just an increasing function. I could write this as an interval notation as well. And it's going to look very much like all our other stuff. 0 to positive infinity. Okay. Interval where y is greater than 0, that's just going to be this section right up here. Okay, that's just going to be that part right there. I could write it like this, negative 0 here as an interval notation. So that's pretty much it. I'll go ahead and get this posted. Again, you should be checking your Canvas for your full notes and utilize these, especially if you're absent. All right, see you next time.